Hello, welcome students. I am Rekha Thorat, Associate Professor. Today we consider some examples of linear differential equation with constant coefficients. Let us consider first example. That is, solve d2y by dx square plus 5dy by dx plus 4y equal to 0. Let us consider the solution of this equation. We first write given equation in the solution, and this given equation can be written in the form in bracket d square plus 5d plus 4 bracket complete into y equal to 0, and we denote this equation as equation 1. Here d means d by dx. D means d by dx. Auxiliary equation of this equation 1 is d square plus 5d plus 4 equal to 0. That means only bracket equal to 0. This is quadratic equation and sum of the roots is 5 and product is 4. So we write this equation as d square plus d plus 4d plus 4 equal to 0. Here product of the roots is 4, which can be written as 1 into 4. 1 into 4, since sum of this 1 and 4 is 5 and product is 4. So that this equation, auxiliary equation, can be written as d square plus d plus 4d plus 4 equal to 0. Hence d into bracket d plus 1 bracket complete plus 4 into bracket d plus 1 bracket complete equal to 0. So that we get d plus 1 in first bracket into d plus 4 into second bracket equal to 0. Hence we get d equal to minus 1, d equal to minus 4. These roots are real and non-repeated. So solution of this equation is c1 e raised to minus 1x plus c2 e raised to minus 4x. Now we consider next example, that is example number 2. Solve d2y by dx square minus 5 dy by dx plus 6y equal to 0. We first write given equation in the solution, and using operator d, this equation can be written as in bracket d square minus 5d plus 6 bracket complete into y equal to 0. We denote this equation as equation number 1. Auxiliary equation of this equation 1 is bracket equal to 0. That is d square minus 5d plus 6 equal to 0. Here sum of the roots is minus 5 and product of the roots is 6. So that we take 6 means minus 3 into minus 2, since sum of the roots is minus 5 and product is 6. So this equation, auxiliary equation, can be written as d square minus 2d minus 3d plus 6 equal to 0. Hence d into bracket d minus 2 bracket complete minus 3 into bracket d minus 2 bracket complete equal to 0. Thus we get d minus 2 into first bracket into d minus 3 in second bracket equal to 0. That is d minus 2 equal to 0 or d minus 3 equal to 0. Hence we get d equal to 2, d equal to 3. These are the roots of auxiliary equation. Hence the solution of this equation is y equal to c1 e raised to, roots are 2 and 3. So that the solution is y equal to c1 e raised to 2x plus c2 e raised to 3x. Now we consider next example. Solve d2y by dx square minus 5 dy by dx plus 4y equal to 0. That is, we consider this first example, but in book there is change in sign. So we have solved the same example in here by correcting the sign. So we have considered this example 1. Now we consider next example. Solve d cube y by dx cube plus 6 d2y by dx square plus 11 dy by dx plus 6y equal to 0. In the solution, we write this equation 1 and we write this given equation using operator d as in bracket d cube plus 6d square plus 11d plus 6 bracket complete into y equal to 0. And we denote this equation as equation 1. Here d means d by dx. Thus we get in bracket d cube plus 6d square plus 11d plus 6 bracket complete into y equal to 0. Auxiliary equation is bracket equal to 0, that is d cube plus 6d square plus 11d plus 6 equal to 0. This is cubic equation, and to find the roots of this cubic equation we use synthetic division method, that is संश्लेषक भागाकार पद्धत. You have studied this method, संश्लेषक भागाकार पद्धत, that is synthetic division in 8th and 9th standard. So you know this method. For this cubic equation, we first check whether the equation is satisfied for d equal to 1. For d equal to 1, 1 plus 6 plus 11 plus 6, which is not equal to 0. Hence d equal to 1 is not the root of this cubic equation. For d equal to minus 1, this cubic equation is satisfied. So we take here d equal to minus 1, and then we write the coefficient of this cubic equation, that is 1, 6, 11 and 6. Then we take first term as it is. 1 into minus 1 is minus 1, 6 minus 1 is 5, 5 into minus 1 is minus 5, 11 minus 5 is 6, 6 into minus 1 is minus 6. Here addition is 0. That means we take here addition. There are 3 terms, so that we get 1 into d square plus 5 into d plus 6 equal to 0. 3 terms, so power is 2. These are coefficient, 1 into d square plus 5 into d plus 6 equal to 0. Thus we get d equal to minus 1 and d square plus 5d plus 6 equal to 0. Now we have to find the roots of this d square plus 5d plus 6 equal to 0. Here sum is 5, product is 6. So the factors are considered as 2 into 3, that is sum is 5, product is 6. Hence this equation can be written as d square plus 2d plus 3d plus 6 equal to 0. Hence we get d into bracket d plus 2 bracket complete plus 3 into bracket d plus 2 bracket complete equal to 0. That is d plus 2 into bracket in first bracket into d plus 3 in second bracket equal to 0. Hence d plus 2 equal to 0, d plus 3 equal to 0. So that we get d equal to minus 2, d equal to minus 3. These are the roots of this equation d square plus 5d plus 6 equal to 0. Thus, the roots of given cubic equation are d equal to minus 1, minus 2 and minus 3. Hence, the solution of given equation is y equal to c1 e raised to minus 1x, that is c1 e raised to minus x plus c2 e raised to minus 2x plus c3 e raised to minus 3x. Now we consider next example. Solve d cube y by dx cube plus y equal to 0. In the solution, we first write given equation using operator d, that is in bracket d cube plus 1 bracket complete into y equal to 0, and we denote this equation as equation 1. Hence, auxiliary equation is d cube plus 1 equal to 0. That is d cube plus 1 equal to 0. We have to find the roots of this auxiliary equation. Again we here use method of synthetic division. For d equal to 1, equation is not satisfied since 1 plus 1 is not equal to 0. For d equal to minus 1, equation is satisfied. So we take here minus 1 and we write the coefficient of this equation. Coefficient of d cube is 1. Coefficient of d square is 0. Coefficient of d is 0 and constant term is 1. Here we first term 1 as it is. 1 into minus 1 is minus 1. Sum of this is minus 1. Minus 1 into minus 1 is 1. Sum is 1. 1 into minus 1 is minus 1. Sum is 0. Here there are 3 terms. So equation is 1 into d square minus 1 into d plus 1 equal to 0. Thus we get here d equal to minus 1 since by putting d equal to minus 1 equation is satisfied, and this equation d square minus d plus 1 equal to 0. Now we have to find the roots of this d square minus d plus 1 equal to 0. Here sum is minus 1, product is 1. But factors of 1 are 1 into 1 or minus 1 into minus 1. But here sum minus 1 is not possible. So to find the roots of this quadratic equation, we compare this equation with quadratic equation ax square plus bx plus c equal to 0, and roots of this quadratic equation are x equal to minus b plus minus square root of b square minus 4ac upon 2a. Here a equal to 1, a equal to 1, b equal to minus 1, c equal to 1, x equal to d. So that we get d equal to minus b, that is minus into bracket minus 1 plus minus square root of b square, that is 1 minus 4ac, that is minus 4 upon 2e. Hence d equal to 1 minus minus plus 1, 1 plus minus square root of minus 3 upon 2. That is d equal to 1 plus minus I root 3 upon 2, since I equal to square root of minus 1. Thus, the roots of given cubic equation d cube plus 1 equal to 0 are d equal to minus 1 and 1 plus I root 3 upon 2 and 1 minus I root 3 upon 2. These are the 3 roots of equation d cube plus 1 equal to 0. Now here we note that here roots are alpha plus minus I beta. Roots are complex, and you know that when the roots are complex, that is alpha plus minus I beta, the corresponding part of solution is y equal to e raised to alpha x into bracket c1 cos of beta x plus c2 sin of beta x. Here alpha is 1/2 and beta is root 3 upon 2. Here alpha is 1/2 and beta is root 3 upon 2. One root is real, other two roots are complex. Hence, the solution of given equation is y equal to c1 e raised to minus 1x, that is c1 e raised to minus x plus e raised to alpha. Alpha is 1/2 into x. Alpha is 1/2 into x, e raised to alpha x, that is e raised to x by 2 into bracket c1. Here we have taken c1, so that we take here c2 cos of beta x. Beta is root 3 upon 2 into x plus c3 sin of beta x, that is c3 sin of root 3 upon 2 into x bracket complete. This is solution of given equation. Now we consider fourth equation, that is t raised to 4 y by dx raised to 4 plus 18 d2y by dx square plus 81y equal to 0. In the solution we write given equation using operator t. Auxiliary equation is bracket equal to 0. Here we put d square equal to t, so that this equation becomes t square plus 18t plus 81 equal to 0. Here sum is 18 and product is 81. So the factors are 9 into 9. Hence, we write this equation as t square plus 9t plus 9t plus 81 equal to 0. That is, in t plus 9, t into bracket t plus 9 plus 9 into bracket t plus 9 equal to 0. That is, t plus 9 into t plus 9 equal to 0. So that we get t equal to minus 9, t equal to minus 9. But t means d square. That is, d square equal to minus 9, d square equal to minus 9. Hence, d equal to plus minus 3i plus minus 3i. That is, roots are d equal to 0 plus minus 3i, comma 0 plus minus 3i. That is, roots are repeated and roots are complex. These complex roots are repeated. Hence, the solution of given equation is, here alpha is 0, beta is 3, e raised to alpha x, that is e raised to 0x into brackets. Roots are repeated, so that in bracket c1 plus c2x bracket complete into cos of beta x. Beta is 3, cos of 3x plus c3 in bracket c3 plus c4x bracket complete into sin of beta x, that is sin of 3x bracket complete. That is, the solution can be written in the form of y equal to c1 plus c2x bracket complete into cos of 3x plus in bracket c3 plus c4x bracket complete into sin of 3x, since e raised to 0x is 1. This is solution of given equation of fourth order. Thank you.